Hi, this is a summary and demo of my final project case study in international bike sharing. Now, what is a bike sharing system? It's a service in which bicycles are made available for shared use to individuals on a very short term basis for a price. Bike share schemes allow people to borrow a bike from point A and return to point B. It is sustainable, like less pollution, and also we can avoid congestion, traffic, etc. Moving on to the project goal and statement. The goal here is to demonstrate how can one build a system that collects bike sharing data by certain criteria and index them into Elasticsearch for further analytics. The big data source used here is international bike share data available on satori.com, and this is a public data source. It contains data of about more than 50 cities across the world. The data looks like here. We are on the bike sharing channel on satori.com, and we can see data is continuously streaming here. The new technologies used here are Apache NiFi and Apache Flink. Going to Apache NiFi was built to automate the flow of data between systems. It has got a very easy to use UI offering drag and drop features. It is seamless, and also we can design, control and monitor data flow easily. The unit of data moving through the system is flow file here. And also we have processors which performs the work and can access the flow files and transfer data. It is highly configurable and also ensures guaranteed delivery. And again, we can build our own processors and more. Moving to Apache Flink. Apache Flink is an open source framework for distributed stream processing which relies on a streaming execution model. It processes unbound datasets like continuous datasets, and streaming execution is continuous processing on data that is continuously processing. It implements actual streaming processing, does not use microbatching. Better support for cyclical and iterative processing. Custom memory management. Though this is built on Java, it does not entirely rely on JVM garbage collection. It also offers low latency and higher throughput. Here we can see the Flink model, and it also supports, as we can see, stream processing and batch processing. The TestString API is the one which is used for stream processing. Moving to the processing pipeline. Here is the streaming data, which has been read by Apache NiFi, and then Kafka is in the messaging tier. Apache Flink. So Apache Flink, along with the Scala program, reads data from a Kafka source and then writes it into Elasticsearch sync, and then Kibana is used for reading the data, like analyze the data, build more reports, pie charts, etc. Coming to the details of the architecture and technologies used, in the collection tier we have Apache NiFi, which is connecting to Satori. Let's go and see how it looks like. So here we can see we have the consumed Satori RTM processor, and here the published Kafka 0.11 processor, and data is getting transferred from here to here, and the average is almost 8.4 MB for 5 minutes. So, and as we can see, the Flink Kafka program is already running here, which is writing data to Elasticsearch sync. Going to Kibana, we can see there is data already. So we can query data here, like we can query for cycle rentals in Australia, and we can see we got the data here. We can go to visualize and create various visualizations like area chart, pie chart, geo grid, etc. Going to the dashboard, I'll open the existing dashboard which I had built. So this has the total count of the events so far. And then we have pie chart for country code. This is the bar chart which represents the top 5 bike sharing given by publishers like the Capital Bike Share or the Citibank NYC Bike Share, etc. And then this is the GeoGrid showing the bike sharing distribution throughout the world. That's it. Thank you.